Hi guys, good afternoon. So today we'll start with the ACL. So we'll see how you can control the ASA traffic. See, by default, what we have seen so far. But if this is our topology, which looks something like this, you have an ASA, you have switches, then you have two routers on the inside, then you have one PC, one router is there, and two routers on the outside, and one management PC. This is how our lab looks like. This one is ASA. This is DMZ. This one is inside R1. This is inside R2. This is your client, or we can call it inside PC. This is your inside switch. Then we have management PC. And then we have outside switch. This is outside our. This is outside. This interface, it is V0/0. This one is V0/1. And this interface, it is Z0/2. This is your management interface, M0/0. Okay. Now there is two types of traffic. Okay. There is two types of traffic that we can control. We can have two types of traffic. Number one, through traffic. Number two, through traffic. What is through traffic? The traffic that will be passing through your firewall. That means if I say, let's say some traffic going from inside to outside, or coming from outside to inside, okay, or going from inside to DMZ. So this is the traffic that is passing through your firewall. This traffic, it is not for your firewall. Okay, this traffic, it is not for your firewall, but it is passing through the firewall. So this is what? This is the through traffic. This is the through traffic. While another type of traffic, which is to traffic, this is the traffic that is for your firewall. That means, let's say from the management PC, if I'm taking access of your ASA, so this traffic will be coming for what? This will be coming for your firewall. So this is what kind of traffic? This is your to traffic. Any traffic that is ending up at your firewall only, okay, not going beyond your firewall. This is what? To traffic. Is that clear? through traffic and to traffic. Through traffic, this will pass through your firewall. To traffic, this is for your firewall. Okay. So this traffic, this is traffic passing through firewall. This is the traffic destined for the firewall. So if I try to ping a firewall, if I try to ping my ASA, that will be what? That will be to traffic. And from inside router 1, if I try to ping outside router 1, that will be what? Through traffic. Okay. If from inside router 1, I'm pinging ASA, this is to traffic. And if I'm pinging the outside router, it will become through traffic. Okay. This is how through traffic and to traffic is defined. Okay. Now what? First of all, we will understand how we can control the through traffic, the traffic that is passing through your firewall. So for that reason, we will require what? ACLs, the access control list. Okay. So tell me guys, what is ACL? What is ACL? What are access control list? What is ACL? Yes, guys, anyone? What is ACL? It is a set of rules in which we allow or deny a specific traffic. Yes, we can say that, right? That ACL is a set of rules that is used to filter incoming and outgoing traffic based on the rules configured. Okay, so that means whatever the rule we will configure in the rule, whatever the you can say action we will define. So we can define permit or deny action. Okay. So granular control of filtering destined to a source and destination. Yes, it can also be said that it provides you granular control over your network traffic. Okay. Now, how many types of ACL is there? If I talk about types of ACL, two types. What are they? Standard and extended. Great. We have standard ACL, and number two, we have extended ACL. What is the difference? Between your standard ACL and extended ACL, what is the difference? What is the difference between standard and in standard complete network is blocked? Okay. And why? Why the complete network is blocked? I can block a specific host also. I can block a specific host also. But in extended, we can deny a particular. No, in standard also, I can deny a particular host. Okay, in standard ACL also, I can deny a particular host. So the major difference, okay, The major difference between your standard and extended access list. Your standard access list filters based on source IP address only. Case of your standard access list, the filtering is done based on the source IP address only. While in case of your extended access list, filters based on source IP, destination IP, protocol, and port number. Okay. You can filter the traffic based on protocol and port number. And this is the reason that your standard, you say that it blocks complete communication or two-way communication. Okay. And with the help of standard, you can block a network, subnet, or host. While in case of extended, you are able to block a network, subnet, host, and a service also. You can block a specific service also, but in standard, you cannot block it. Okay. Then you can say that, okay, in case of standard, since it is just checking the source IP address only, so your two-way communication is blocked. Okay. And in case of extended ACL, you are able to define specific protocol, port number, or message type. So that is the reason that with the help of extended one-way communications, okay, if you want, you can block one way. If you want, you can block two-way. That is up to you. Okay. This is one of the difference. Now, if I talk about, the way you can define an ACL, how you can define an ACL, what are the methods? What are the methods to define ACL? List, group, etc. No, like, two methods we have: named method, numbered method, correct? So there are two ways to define an ACL. What are they? Those are numbered and named. So in your standard ACL, okay, so like if we define ACL, I can say ACL, and then you have standard, then you have extended. Then under the standard, you can define it in named method and numbered method. Numbered, named. Okay. And the same two categories, in the same two methods, you can define your extended also. Now, if we talk about the number range, so what is the number range for your standard numbered? What is the number range for your standard ACL? By default, it is 1 to 99. And for extended, it is 100 to 199. Now this is the normal range, but there is also an expanded range, which is from 1300 to 1999 and from 2000 to 2699. This is the expanded range. Okay. And this is the normal or default or standard range, you can see. Now understand in your ASA. Okay. In ASA, only named ACLs are supported. There is no numbered concept, only named. Okay, we don't have numbered concept in your ASA, we just have the named concept. That means we won't be using this. Even if you give a number in case of ASA, so it will consider it as a name on. Okay. Then what? If you want to define, let's say I have a router. Yes, Archana, I need out. Archana, need out. Okay. All right. So let's consider we have a router here. Okay. This is the kind of scenario we are considering. This is your PC1. This is your router. This is your PC2. Now let me consider that here I have an IP 10.1.1. And this is my interface 0/0. And here I have an IP 10.1.10. And this is my V051 interface. And this is I'm having 10.2.2.10. And here let's say I have 10.2.2.3. So my PC1 will communicate with PC2, right? And I want that my PC1 should not communicate with PC2. This is my requirement. I want to filter the traffic of PC1 from PC2 so that there will be no communication between PC1 and PC2. So if I want to create an ACL in a router, how would I write the ACL in the named method? What would be the syntax? What would be the syntax for named ACLs in a router? So normally I would say that, all the named method comments, they start with the word IP. So I would say something like IP access list. And if I'm creating a standard, I would say standard. If I'm creating extended, I would say something like extended. Okay, so like this, I would say, let's say right now I'll go with standard. Then I would give a name. So let's say I would give something like block PC1 to PC2. Okay, this is what I'm willing to do. Then what I would do, I would give a permit or deny statement. So right now I want to deny, then which host, and I want to deny, let's say 10.1.1. Or if I want to deny entire network, I would say deny 10.1.1.0. Okay. And if it is /24, I would give 0.0.0.255. Okay. This is how would I give, right? So in ASA, what happens again? First of all, we don't have this IP comment. Okay. Your comments will not start from IP. And we don't have this wildcard concept also. In ASA, there is no wildcard concept in none of the concept. Okay, whether it is you are performing ACLs or you are doing NAT or anywhere you use wildcard, right? So you don't require even in the OSPF and all, right? So you don't require the wildcard mask. You require only subnet mask. So in case of ASA, you don't have this wildcard concept. So one is it will support only named ACLs, and the second thing, ASA support only subnet mask. Okay, there is no wildcard support. Okay, all right. So now what we are going to do, we are going to try to filter out some traffic. Okay, so let me bring up the lab. And before that, let's see if there is something available here. CLI video introduction to access list. So access list is one of your main features of your ASA. And ACLs, they will permit or deny traffic and can override the security levels of ASA. So what does it mean? It means by default, we all know, right, that if I open the topology, by default, we all know, right, that so in case of ASA, we all know that, this is security level what? This is security level 100. This is security level 0. And ASA follows what? Waterfall model. This model. That means by default, high security level to low security level, traffic will flow. But if the traffic is trying to go from low to high, this traffic will be dropped. Okay. So this is because of the security level. But if you create a rule that, okay, allow anything that is coming on this interface. If you create a ACL something like this, that permit any from any source to any destination. In that case, what will happen? That ASA will override. Now these security levels will not be effective. The traffic will start going from lower to higher security level also. Okay. So this is what we are saying here, that ACLs, they will permit or deny traffic and they can override the security levels of ASA. So how the access list, like how the access control list will be used. So first of all, you have to decide the direction of traffic, that which traffic you want to permit. Okay. Then we must know that where is the source, where is the destination. About the source and destination, we must know from where to where you want to allow. Then we have to decide that, okay, whether the traffic is inbound or outbound. So direction also we have to decide. And then we apply it on the interface. Okay. So let me go. Okay, these are some of the terminologies that will be used. Deny, permit, source address, destination address, inbound and outbound. Inbound is incoming traffic. Outbound is outgoing traffic. Permit means allow. Permit means allow. Deny means block. Source IP means source address means which is the source IP address from where the request is coming, and this is where the request is going. Destination. Then after type of ACL, we have already seen standard, extended, numbered, named, all these things. Then there are certain rules. So what are these rules? You can assign only one ACL per interface per protocol per direction. Okay. You can assign only one ACL per interface per protocol per direction. That means either you can have one in inbound or like only one ACL you can have in the inbound direction and only one you can have in the outbound direction. So in one direction, you can apply only one ACL. If you try to go with more than one, in that case, it will override the previous access control list. Okay, so that means the old ACL will be removed and new ACL will be effective. Okay. And we cannot remove a rule from a access list if we are using numbered. So this concept is not there in the ASA. Okay, so we don't have to consider this thing, that this thing is not applicable. And if we try to remove, this is for a router, okay? This rule is for a router, not for a ASA. In ASA, we don't have the numbered access list. So this rule will not be applicable. Whatever the new rules you are adding, right? So it will be placed at the bottom of the access list. So let's say first rule I'm creating. So first rule will be added. Okay, it will have a, let's say, line number 1. Then you will create another rule, so it will go below this, line number 2. You add another one, it will go number 3. Like that, it will be added at the bottom of your access list. So before implementing your access list, you must analyze the whole scenario carefully, that what you are trying to achieve. Okay, why? Because there is a possibility that, okay, I'll say that, okay, I want to block PC1. Then I will say that here, let's say, for example, in the second rule, I'll say permit any. That means permit everything. Then in the third rule, I will say block PC2. So what will happen whenever the traffic will hit the root ASA interface? What will happen? ASA will first match the first rule. Matching, not matching. ASA will check the second rule. Okay, let's say this is coming from PC2. So ASA will check the second rule, permit any. ASA will permit it. It will never check the third rule. So you have to understand the whole scenario first, that what you're trying to achieve with the help of access list, how you are trying to filter out the traffic. And accordingly, you have to decide your access control entries. Okay. Then at the end of every ACL, there is an implicit deny statement. Okay. So what is this implicit deny going to do? It will deny every other traffic other than whatever the ACL you have configured. So again, this thing will not be very effective in the ASA, because in ASA by default, everything is blocked. We will just be allowing the traffic. Specifically, we will be allowing the traffic. So we should have at least a permit statement in our access list. Otherwise, all traffic will be denied. So in ASA, it is by default from outside to inside, all traffic is denied. So we don't have to worry about that. Then standard access list and extended access list, they cannot have the same name. This is very important. You cannot mix up two different kinds of ACL. I cannot mix up a standard ACL and extended ACL. Okay. This is not allowed. This thing is clear? Any doubts up till now? All good. Then where to apply the ACL? So ACLs you will apply on the interface, and depending on the direction of traffic, right? So right, like this traffic, it is going like this. So what will happen? It is entering on this interface. So this will be known as inbound. From this interface, it is going out of the router. This will be known as outbound. Same way, depending on the traffic flow direction, your inbound and outbound will be selected. So if the traffic is incoming, it is inbound. If the traffic is outgoing, it is outbound. So you can apply the ACLs in an inbound or outbound interface of a device. So applying an access list to an inbound interface controls the traffic that will enter the interface. That means if you apply the ACL in the inbound direction, it will control incoming traffic. If you apply it on the outbound direction, then it will control outgoing traffic. And these are the similarities between your router and ASA access list. So what are the similarities? That first of all, each ACL is made up of one or more access control entries. That means one access list can have multiple entries. Then they will be processed sequentially from top to down. That means line by line, they will be tested. And it follows the first ACE match. That means as soon as there is a match, it matches a condition, it will not check the further conditions. It will exit. Then they will have a implicit deny at the bottom. Okay. Then both they supports remarks added for AC for ACL. So you can add entries and you can tell about them that, okay, why you are adding them. your router and ASA, they both follow one access list per interface per protocol per direction. That means on one interface, you can apply only one ACL in each direction. So one in inbound, one in outbound. Both ACLs, they can be, okay. ACLs can be enabled or disabled based on the time ranges. So you can enable or disable the ACLs based on time ranges. That also you can do. Now, if we talk about the difference, major thing is what? What is the difference? So your router ACLs, they uses what? They uses a wildcard mask, correct? Your router ACLs, they will use a wildcard mask, but ASA uses what? Subnet mask. Then ASA has named only, while router can have both numbered and named. Both the types of ACL router can have. Okay. And by default, security level apply access control without an ACL configured. So if you want to filter the traffic, by default, security levels will filter the traffic, but your ACLs can be configured to filter the traffic further. Okay, to allow or deny the traffic as per the requirement. These are some of the rules. Now, this is through the packet filtering, through the box packet filtering. Okay. So right now, what I was discussing about the traffic that is passing through the firewall and the traffic that is for the firewall. So through traffic is what? Traffic that is passing through the appliance or through the firewall from one interface to another interface. And this configuration, it will require ACL to be defined and then applied to an interface. So we can filter the through traffic using the ACL. Then to the box traffic, so also known as management access rule, it is used to filter, introduced to filter traffic that is destined to the control plane of the ASA. That means the traffic that is going to the firewall. And it is completed in one step, but requires an additional set of rules to implement access control. So generally, you cannot filter out, the to the box traffic using ACL. That part I'll show you. Practically with with lab, I will show you that, okay, these things will not work. What? That you cannot use ACL to control to the box traffic. Okay. We have to go with another comments, dedicated comments are there. While through traffic, we can control using the ACLs. Okay, so this was a theoretical part. Now let me go for the direct practical. Okay, these devices. Let me power them. This device we don't require. So what we'll be doing, first of all, we will be testing the connectivity, and what we are going to see, we are going to see that, outside R1, the reply will come and the reply will be blocked. Okay. Or initially your outside router one, it will not be able to take a telnet access of your inside router one, and we will try to allow the telnet. Let the device is fine. So now take access of ASA. Inside router 2, DMZ, outside router 1, and outside router 2. router came up. ASA also. By default, when you start the lab in Eve, what will happen? The interfaces will be in the downstream. Okay. So if you check show this is router. So show IP interface with. So you can see by default, when you start your lab, even though you have saved the configuration, you gave the no shutdown command, the interfaces will be in the downstate. Make sure whenever you start your lab to go to the interface in the router and give the no shutdown. And this will happen with the router only. With the other devices, the interfaces are by default off. Like ASA, you can check. Interface IP read. In ASA, it is by default up. But with router only, this is the scenario. Okay. Wait one moment, please. Here also, so IP interface brief, all the interfaces are up and down it is. So this is 0 shut down. Now I'll go and do it directly in the all devices. Configuration terminal, interface is 0 I'll say no shut. Outside router 1. Configuration terminal, interface is 0 no shut. And here also. Interface is 0 no. Now, as of now, we have configured all the security levels and everything correct. We can check show naming. So I can see that, okay, my inside is having security level of 100, DMG having security level of 50, outside is having security level 0, and management is having security level of 100. Okay. So now what? See here. From high security level, that means from my inside, the traffic should travel to outside. There should be no issues with this. Okay. There should not be any issues with it. Why? Because it is traveling from high security level to lower security level. And by default, TCP and UDP inspection is there. So that means if I'm taking a telnet access, I'll be able to access outside router 1. And my ASA will allow the return traffic. So let's check. So I'll say telnet 11.1.1.1.5. And you can see I have the access. Username Cisco, password is Cisco. So this is the access I got for outside router 1. But do I have an access if I try to go from outside to inside? Will I get the access? No, I'll not get the access. Why? Because the traffic will be going from lower security level to higher security level. Okay. So I'll say configure terminal. So not configure terminal, telnet access I want. And telnet access I want for inside router 1. So my inside router 1 IP is what? It is 10.1.1.125. So I'll say telnet 10.1.1.125. So right now I'm not getting the access. So that means in the ASA, I'll have to create an ACL. Okay. In the ASA, I'll have to create an ACL. And what is the ACL I need to create here? I need to say that when the traffic is going from my outside router 1, okay, when it is going from here to here, this way, this will be the traffic flow. What is the action it should take? Permit. It should take a permit action. Now, which service I want to allow? So let's say I want to allow telnet only. So looking at my traffic flow, that what I'm trying to achieve, I got to know few informations. What is it? First is I got to know about the source IP, that okay, I have to say that this is the source 10.11.125. Then I got to know about the destination IP. Okay, what is the destination? 10.11.125. Then which protocol? Which protocol I have to allow? Yes, guys, which protocol I need to allow? Telnet is a TCP based protocol, right? So I'll be allowing what? TCP. And what is the port number I need to allow?
23.
23. This is the details I got to know. Okay. Then based on my traffic flow direction, my ASA is dropping the packets. As of now, my ASA is dropping the packets here. So if I check on this interface, what will be my traffic direction, inbound or outbound on this interface? Because the traffic is flowing like this, right? Going from outside to inside. So on the Z0/2 interface, this will be inbound. So direction also I came to know that, okay, on which direction? Interface also I came to know. So this is my what? This is what my outside interface. So on the outside interface, in the inbound direction, I have to apply this ACL. And these are the details of the ACL that I will create. Now let's go and create the ACL. So what I'll do, I'll go to the ASA. In the ASA, go to the global configuration mode. Then I'll say access icon list. Okay. Then after here, you have to give a name to your ACL. Okay. You have to give a name to your ACL. So you can give any name, relevant name, whatever you find comfortable. Right now, I'll simply say out to in. That means from outside to inside communication, I'm trying to allow here. Okay. Then after, next thing is what? What is the action I want to take? I want to deny or permit. Okay. So I want to do what? Right now, I want to permit because by default, the traffic is denied. Okay. I'm permitting the traffic. Then after, I have to tell about the protocol, that which protocol. So as of now, we saw that right now we will be going with the TCP protocol. So I'll say, I want to permit what? TCP. All right. Then I have to give the information about the source IP address. Okay. I have to give the information about source IP address. So let's say that my source IP address, and since I'm allowing only R2 only, so I can use the word host. Why? Because specific host I want to configure right now. So let's say I want to allow the host 11.1.1.25. This is the source. What is the destination? So destination also is a single host 10.1.1.125. Then I have to give here the port number information. Okay. So specific port number, less than, greater than, a range of port numbers, whatever you want to block or allow, you can do that. Right now, we are giving a specific port. So we will use the equal to operator. So I'll say port number equals to, now what is the port number you will give? So you can give it from 1 to 65,535, anything. And there are some ports or some services for which dedicatedly they are using name also. So directly here you can mention that you are trying to block telnet service, or else you can simply give the port number 23 also, both are fine. Hit enter. Now if I check show running access test. So you can see this is the ACL I have created. So I gave the port number 23, but it has automatically taken the name as telnet. This is the access list I have created. But still, if I check, will I have the access from outside? So even though I have created the access list, still I don't have the access. Why I don't have the access? Because I have to apply it on the interface. Okay. So we will be applying it in the inbound direction on the outside interface. So let's go and apply it. So I'll say access hyphen group. Okay. Then you will give the name of your ACL, which is outside to inside. Okay. Then what do you want to do? Okay. You said access group, you gave the name of your access list. Now, in which direction you want to apply it? In the inbound direction, right? This is for input traffic or incoming traffic. So I'll say inbound. On which interface you want to apply it? I want to apply it on the outside interface. Okay. Done. Now try to take the access. And see. This time we have the access. Let's go. I got the access for inside router 1. Now this will give me access of inside router 1 only. If I try to take access of inside router 2, again, I will not have the access. Okay, check here. If I access, and if I say 126, so I'll not get the access. Okay, here I'll not get the access. Other than that, see, we have allowed only outside router 1. So if your outside router 2 tries to take an access of 10.11.125, see, 10.11.125. So even this will not get the access. Why? Because source and destination is specifically mentioned. That which source, which destination, which protocol, which port number, everything we have mentioned. And based on that, we gave the action also, but this will not be allowed. So we don't have the access from outside router 1 to the R2, and from the outside router 2 also we don't have access. Only when outside router 1 will access the inside router 1, then only you will get the access, depending on what the ACL you have configured. This is clear? Yes or no? Okay. Now what? If I try to ping, okay. If I try to ping from my inside router 1 to the outside router 2. Okay, understand the scenario. I'm trying to ping from inside router 1 to the outside router 1. So this traffic is going from higher to lower security level, going like this. So what will happen? Will my ping request or ICMP ACO request, let's say, my ICMP ACO request, will it be permitted or not through the firewall? It will be allowed. Why? Because this is going from a higher to lower security level. But when the reply will come, in that case, what will happen? Will the reply be allowed or not? Reply will be denied. Why? Because no ICMP inspection. We'll see how we can enable the ICMP inspection. Okay. But as of now, this is dropped here on this interface. Okay. It is dropped on this interface, and it is what? ICMP ACO reply. Now I want to create an ACL to allow this reply. I want to create an ACL to allow this reply. So tell me, in the ACL, what will be the source IP? In my ACL, what will be the source IP? .11.1.1.125, correct. What will be the destination IP? .10.1.1.125. What is the protocol? Protocol will be ICMP, and the message type. What will be the message type? Message type will be 0. Okay. Then on which interface I will apply it? I will apply it same outside interface, and since the echo reply will be coming from outside to inside, so that means on this interface, what will be the direction? In which direction I will apply it? Inbound or outbound? Inbound, right? So on this interface, again, I will apply it inbound. Okay, so then let's go and create a rule to allow this traffic. So right now, if I check my inside router 1, okay, enable, if I try to ping 11.1.1.125. So right now, I'll not be able to ping. Okay, not able to ping. Now let's create the rule. So we'll say access hyphen this. Then let's say this time I'll say permit echo reply. This is the name I have given to this access list. Then what is the action I want to take? I want to permit. Then which protocol? I want to permit the ICMP protocol. From which host? So from the host 11.1.1.125 to which host? It will be going to 10.1.1.125. Then what is the message type? So either I can say here 0, or specifically here it is mentioned that, okay, echo reply I can permit. So I can say that I want to permit echo reply. Done. Now I have to apply it on the interface, right? So we had already created one ACL and applied on this interface. Now you will see that thing also, that on one interface, only one ACL can be there. Okay. So if I say right now, show running access group. So right now you can see I have one ACL already running in the inbound direction on the outside interface. Okay, now what I'll do, I'll apply the second one also. Access hyphen group. Name is what? Permit echo reply. Make sure the name is and name and case, everything is correct. Then you want to apply it in the inbound on the interface outside. Done. Let me check again. See, earlier I had this command, and now when I check, it has been replaced. So what will happen? Now my outside router, it will not be able to take a telnet access because my previous rule was overwritten. And if I try to ping the rule we created right now, right, that I want to allow the echo reply. So now this echo reply will be permitted. See? So like this, I can create rules. Okay, I can create rules. So now tell me one thing, what if I want to perform both the things? I want to allow echo reply also, as well as I want that, okay, my outside router 1 should be able to take telnet access of my inside router 1. Okay. See here. Our traffic flow in the echo reply was this, right? So that means it was getting filtered on this interface. And the traffic direction is what? The traffic direction is inbound. So on the outside interface I applied it in the inbound direction. Okay. And this is the reason that your comment, okay, your comment was that you said access group permit echo reply inbound direction on the interface outside. Okay. Now my question is that I just came to know that on this interface, on one interface in one direction, I can apply only one ACL. On one interface in one direction, only one ACL I can apply. Now my requirement is outside router 1 should be able to telnet inside router 1. And your inside router 1 should be able to ping your outside router 1. Both the things I want to perform. How can I do that? How can I do that? Because on one interface, I can apply only one ACL. But what if I have to permit both of the things? I want to allow both the things. That from outside to inside also include multiple conditions in one rule. Very right. Okay. So we saw, right, that you have one ACL, one access control list. But under one ACL, you can use multiple ACEs. That is access control entries. So that means the name of ACL, I can keep it out to in only. The name of ACL, I can keep it out to in only. And in this ACL, I can define both the rules. That means in the same name access list, I can create two rules. And that will do what? That will allow both the things. So let's see. But again, first, whatever the AC, see here, whatever the rules you want to create under one ACL, make sure that they are hitting on the same interface in the same direction. If I have one rule that is for this one and another rule I have that is going for outbound traffic, so those two rules, if you use in the same ACL, ineffective, because the ACL eventually you will be applying it in one direction only, either inbound or outbound. So make sure in one ACL, whatever the rules or the ACEs you will create, they should be in the same direction on same interface. Do not mix up, different things. Just make sure you apply only the ones which are in the same direction on the same interface. Is that clear? Yes or no? Okay, great. So now let's create. I'll go and remove it. And see, if you want to clear all the ACL configuration, you can simply say clear configure. Clear configure access list. Okay, and this will clear all the configuration. Show access list. You don't have any access list right now. Show running access group. No access group right now. Okay, like this. Now what? Let's create. So first rule I will create for outside to inside. I'll say access list out to in. Okay, I'll say access list out to in permit TCP from the host 11.1.1.25 to the host 10.1.1.1.25, which is my inside router, and port number equals to 23. This is one rule I have created. Then another rule I'll create for allowing the ICMP echo reply. So I'll say access list. Name I will give the same. Then I'll say permit, this time ICMP protocol from the host. Okay, when the reply will come. So again, the reply will be 11.1.1.1.25. Destination will be 10.1.1.1.25. And port number, not port number, message is what? Echo reply. In case of ICMP, you will have message. So now you check show running access lists. These are the access lists I have created. Now I need to apply these two access lists. So I'll apply both of these access lists in the inbound direction in the outside interface. Okay. So I'll say access group. Then after, let's say name is out to in the inbound direction on the interface. Which interface? Outside. Here you have to give the name of the interface. Okay. See, slight mistake. I used hyphen, but here it is underscore. So it said this access list does not exist. So I have to use here underscore. And now it is like show running, or directly let me show access list. So now you can see my two ACLs are created. Okay. These two ACLs, these are created right now. So here in the routers, you generally see that the sequence numbers come like, 10, 20, 30 like this, but in router, in ASA, it comes like line 1, line 2, like this it will come. Okay. So these are the two access lists. Right now, you can check the hit count is 0. That means no traffic was matched with this particular access list. And then we have applied it on the interface. So show running access group. So we have applied these ACLs on the inbound interface, outside interface in the inbound direction. Now let me check. So from outside, first of all, let me check the telnet. So I'm getting a telnet. Okay. Exit it. Then after, I'll go here and I'll say ping 11.1.1.25. So this way, it will be 11. Is it clear? All right. Now let me do one thing. Let's say I'll connect one PC here. Outside. Stop the switch. And here. Access that. So now what we will do, we'll try to create, see from outside PC, if I try to take a HTTP access of inside router 1, will I be able to access it by default? No. Okay, so we'll have to create an access list. So now let me give here test 1, 2, 3. IP address I'll set here 11.1.1.5 and gateway IP address will be what? 11.1.1.10. IPv4. Now this will be 11.1.1.5, 255, 255, 255, 11.1.1.10. Close. And if we have connectivity with the gateway, then we will get here network. Okay, so we got network 3. That means we got connectivity with the gateway. Okay. So right now, if I try to take an access, okay, if I try to take an HTTP access, I'll not be able to take. So IP address is 10.1.1.120. Okay, so I'll not get this access right now because my firewall will drop the traffic. So if I want to create this rule to allow it that, okay, from outside PC, I should be able to take what? The HTTP access of my inside router 1. Now again, if we try to check, right now I don't have the access and the traffic direction if we see, so the direction of traffic, you're going from here to here. So direction of traffic will be this one. Okay. So tell me what will be the source IP in my access list? How do I verify the traffic drops or blocks in the ASA? So see, if you have created by default, it will drop all the traffic. By default, ASA will drop all the traffic that is going from outside to inside. Okay. But if you have created an ACL specifically to drop a traffic, let's say everything is allowed, and then you are creating ACL to drop the traffic. In that case, it will be there in the hit counts. Otherwise, this is the default behavior. Okay. That only TCP and UDP inspection is there. So that is also from inside to outside only, and outside to inside, everything is blocked. Everything is blocked. Is it clear? Yeah. So what will be the source IP in this case? When I'm going from outside PC to inside router 1, and I want to create an ACL to allow HTTP. Okay. So source IP will be, it will be 11.1.1.5. What will be the destination IP? It will be 10.1.1.125. Protocol, protocol will be TCP. Port number will be 80. Okay, right now just HTTP. If you want to allow HTTPS also, in that case, you will use 443 as well. Then you'll have to create two rules, okay, to allow HTTP and HTTPS both. So as of now, let's go with HTTP only. So now, on which interface it will be applied, inside or outside? On which interface it will be applied? It will be applied on the outside interface. In which direction, inbound or outbound? It will be there in the inbound direction. Correct. Okay. So let's go and create this rule. So So already we have one access list right here, outside to inside. So in the same access list, I will add one rule for the HTTP also. So I'll say access list out to in. I want to permit TCP from the host 11.1.1.5 to the host 10.1.1.1.25, port number equals to 80. Done. Show access list. Okay. So right now you can see hit count is what, 0, and it has considered it as www. That means web traffic, internet traffic. Okay. So now let me go to the outside PC and let me try to refresh. Do you see it is asking me this time about username and password? So username Cisco, password is Cisco. And see, we got the access. So this way we can allow. Now we allowed only HTTP. If I try to go using HTTPS, in that case, see what will happen. I will not get the access because HTTPS, my firewall will drop. We haven't created a rule for it. Okay, see, we didn't get the access. And if I create one more rule, same kind of rule just for port number 443. Now check. Now my firewall will allow and I'll get the access. So I got it. Connection is not secure because of the certificates and all. I'll say add the exception and confirm the security exception. You see, this time I will get HTTPS access. Cisco, and see, this time the website is HTTPS, not HTTP. And also you can check whether the traffic is hitting your access list rules or not. So you can see here hit counts are increasing. So that means the traffic is hitting your rules. Is it clear? Can we reset the hit count? So you cannot reset the hit count. You can just remove and recreate the ACL. Okay. Like this is not something like, in case of VTP, these kind of problems happens that there is a configuration revision number. So you need to reset it before, you can say like, you need to reset it before installing a new switch into a network. Otherwise, it might wipe out all your VLANs, right? Is there any limit? No, there's no limit you can create. You can create as many as you want. Okay. But definitely there will be a limit to a memory. How much memory is there in your device? Okay. All right. So I believe you got the idea how you will be creating the ACL, right? How you will be applying the ACLs. This part is clear. Okay, great. Now we will discuss about packet flow. But before that, let me give you a task. We have to understand the packet flow. Just to confirm, adding no before the ACL removes it. Yes, adding no before the ACL will remove the ACL. You just have to, if you want to remove a specific entry, then you have to include the line number. Okay, let's say, for example, this thing that I show you. Okay, here, let's say I want to remove only this entry. Only this entry I want to remove. So I can just, either I can directly copy this along with the line number and then I can paste it. This is the entry. And I can append a no here and check. That line is gone. And now number 4 entry came at number 3. Okay, so if I will bring it again using line number 3 only, okay, this way you can add also. whatever the rule you want to create, in that rule, after the name, you add the line number. If you add the line number, automatically this will be injected at number 3 and number 3 will become number 4. Check. Again, back to the same. Yeah. And if you see something like this, no access list out to in data. So this command will be. That means accidentally you cannot remove your entire access list. You have to go with a specific entry itself. If you want to remove all the ACL, then you have the command clear configure access list. This is the command, and this will remove your entire access list. Yes, in this way, by adding line numbers, you can arrange your ACLs. Okay, you can decide that, okay, which ones to be matched first. Okay. Now, the task. So what do you have to do? You have to allow from inside to DMZ. Will I be able to take an access or not? Inside to DMZ. From here to, from this PC, if I try to take HTTP access, I'll be allowed, right? So what do you have to do? You have to create a rule that from DMZ, your DMZ server should ping what? Your inside PC. Okay. Your outside PC should take an access of DMZ. Okay. That means it should take HTTP access as well as telnet access. Here you have to allow HTTP and telnet. Here you have to allow ping. Okay. Then after, you can say that, okay, your inside router 2, this should be able to ping as well as take SSH access of your outside router. Okay, these three are the tasks. Okay, DMZ server should be pinging your inside PC. Your inside router 2 should be taking access of your outside router 2. So using SSH, it should take access and it should allow ICMP ping also. Then after, your outside PC should be able to take HTTP and telnet access of your DMZ server. So these are the access lists you have to create. Clear? The task is clear, right? Okay, great. Practice it, and if you face problem, tomorrow we will discuss about it. Now let's go for the packet flow. There is a packet flow we need to understand. Okay, packet flow on the ASA. So ASA has two packet flows. One was till the version 8.2. This is the iOS version, and after the iOS version 8.3. So currently this one is being used. Okay. So earlier what was happening? Whenever a traffic is hitting on an ASA interface, let's say this is an ASA. Okay, this is, let's say, inside, this is outside. So whenever a traffic is hitting on the ASA interface, ASA will first check what? Connection table. Okay. ASA will first check what? Connection table. So if there is existing connection available, then it will forward according to the connection. If there is no connection, then ASA used to create the connection. In the connection table, ASA will make an entry. Then after, ASA will check, is this traffic filtered or not? Is there any ACL that is allowing or blocking this traffic? So it will check if there is an ACL that is allowing or blocking this traffic, then what your ASA is going to do? ASA is going to take the action. Then after, if okay, it is permitted, then what your ASA will check what? Translation. That okay, when it is going out, so is there any NAT done? Translation or untranslation has to be done. So ASA will do the translation of untranslation, and then according to the routing table information based on the destination IP address, ASA will perform the forwarding. This was the packet flow. So let's say this went, and let's say this guy is trying to go using ICMP. This is ASA. Okay, and consider this is your 10, 1, 1, 125. This is 11, 1, 1, 125. Okay, so it was going from higher security level to lower security level. So was not an issue. It was sent. Okay, and let's say here outside interface IP is 11.11.10. So NAT was being done. That means when the packet is coming from your inside router to the ASA, it was having source IP as 10.1.1.125. But when it was going from ASA to the outside, so it was having source IP as 11.1.1. Now, when this guy will respond, to which IP it will respond? 11.1.1.10, right? The one it received. So when the reply will come, reply will have the destination as 11.1.1.10. Now what will happen? Again, the traffic will come. ASA will check, is there any existing connection in the connection table? If there is, then it will forward. If there is no, then it will create the connection. Then after it will check the ACL. That do you have created any ACL? So tell me one thing here, that when you have to create an ACL for this interface. So right now, how did we create the ACL? That source is 11.1.1.125. And destination we gave what? 10.1.1.125. This is how I gave, right? In the ACL. That host this to this. But this time the packet is coming to this address, 11.1.1.10. So that means in my ACL, I have to give not this IP, but this IP. If I say 10.1.1.125, my ACL will be tested, it will not match the rule and this traffic will be dropped, even though I have created ACL. Okay. So that means I'll have to create an ACL using my public IP. Are you getting it? That what is the problem here? That when I will be creating ACL for allowing the traffic from outside to inside, I will have to give a public IP. With private IP, I cannot do that. And what if I'm using a PAT concept? Everybody will be having the same IP. Big problem, right? So this was not very efficient. And that is the reason that in the newer version, these entries, these were shuffled. Okay, these entries, these were shuffled. So now what? Your translation was getting checked first. So if this IP address is coming, your ASA will first check the NAT. That okay, is there any untranslation to be done? So ASA in the translation table, it will find the entry and it will translate it back to 10.1.1.125. And now after that, it can apply the ACL and it can take the routing decision. Got the differences between the version 8.2 and whatever the packet flow, the newer packet flow? Yes or no? All right, great. So right now, what packet flow we are using is this one. This is the packet flow that is being used. And currently we are going with the 9.2 version. Okay. So this is how your ASA makes forwarding decision. First of all, existing connection, it will check. Then it will check whether there is a connection or not. That means you can say your ASA, first of all, it will check the connection table. Then it will check what? It will check your translation table. That means accelerate table. Then third, it will check ACL. Fourth, it will check routing table. This is how your ASA will make the forwarding decision. Okay. This is clear. Now, after this, the next part we have to discuss is about how you can control the two traffic. Okay. Today we have discussed about the traffic that is passing through the firewall. Okay. That means that is either going from inside to outside or outside to inside. This was your through traffic. Okay. Now, next session, tomorrow, we'll discuss about to traffic. We will discuss about to traffic. So in the two traffic, tomorrow we'll see how we can control, if you want to take a telnet or SSH of your firewall, how you will take it. Okay. Then we will also see how you can manage your firewall graphically using the software ASDM. Okay, so these are the things that we are going to see. So first we have to see about telnet, SSH, ICMP to your firewall. These are the protocols that we'll be testing on to the firewall. Okay, then HTTP also we will be testing using the ASDM. Okay, so this is the upcoming part, that how we can manage to traffic of your firewall. Okay, so this we will start tomorrow. Today you guys practice with the ACLs, and if you face any problems, just drop it in the group and we'll discuss. Clear? All right. If I started NJAPS along with this directly NJAPS, you can, but see, NJAPS is know-how related to your ASA. Okay, but if you had done FTD, that would be better. That would help you understand the deployment and all. But you can check, maybe Susil sir might be telling about the deployment and everything. Okay, just give one moment.